Hi everyone, today I want to introduce you a third-party library called react.js. You can use it to replace React context. It can not only improve React context efficiency, but it can also make the code simple. The author is Daishi Kato. He is also the famous state management library Zustand's author. Currently, the react.js has 2002 stars in Github. Okay, let's look at an example at first. This example was actually introduced in my last video, React Context. If you don't understand the React Context, you can check out my last video. I put it in the description. This example is a user info display system. We have a happy young guy, he is 18 years old. Every time I click the happy birthday button, he gets 1 year old. Happy birthday, he gets 1 year old. What about the next box? It's about his saving. I can give him money by clicking the add saving every time 1,000 euro. This is what we have done in the last video with React context method. It looks perfect. But it has a rerender problem. What is it? Let's look at the code first. The myContext provider component contains all the data I want to pass. Let's go into it. And we will see the age, add age saving, add saving. There are 4 data which we want to pass to the 2 boxes. The age info component is the box that displays the age, and the saving info is the box that displays the saving. So, how do we check if the component has been rendered? It's easy. There is a little trick. Let's go into the age info and here add a line code math random. This code will create a random code whenever the component re-rendered, so that we can track whether the component is rendered. Let's try it. Happy birthday. Happy birthday, the component is re-rendered. And we can do the same thing for the saving info component. And go here and add the same code. Add saving. Both of the components are re-rendered. It is strange if I only add age without add the saving, and both of them are re-rendered. Also, we can do the same thing for the saving. We add saving without add age, but both of the components are re-rendered. It is definitively not what we want. Why? Because if your project is small, it won't affect you in any way. But as your project gets bigger and more complex, it will slow down your app speed. The simplest solution is split this myContext provider into 2, one for age data and one for savings data. Then place these 2 providers of age info and saving info, respectively, so they won't interfere with each other. But in practice, you don't want to separate them because there is a very close logical relationship between the data and they should not be stored separately. In this case, we can use react.js instead of React context. It tracks the change in data to decide whether or not to render the component. It's similar to React context, but the code is cleaner, easier to understand, and more efficient. To see how it works, let's look at the diagram at first. On the left side is React context. I've already spoken about it in my last video. On the right side is the React.js. Let's look at the left side first. It uses create context to create the data store and use context to receive the data. Correspondingly, at the right side, React.js use create container and use tract to store and receive data. The structures are very similar. On the left side, create context returns a context object, under which there is a provider component which stores all the data you want to pass. You wrap this component outside the components you want to pass data to. Also, on the right side, create a container returns a container object, which also has the provider component, which contains all the data that you want to pass. And you wrap that provider around the components that you want to pass the data to. Okay, that's the same part. Let's look at the difference. Initialization of React context is a bit tricky. You have to tell the data structure in create context first, and then go to the provider to formally initialize it again. But in React Tract on the right side, you can directly initialize the data in create container. The only thing notice is that you have to use a custom hook to initialize it. We will talk it later. There are also differences when you read the data. In the left React context, you need to use a useContext hook, pass the context object as a parameter. In the right side React Tract, you can directly use the useTract under the container object to read the data. Now let's see how to write the code. At first, go to the app file and find the My Context provider. Control-click, go into the My Context provider, find the create context. And the first step, we should convert the create context to create a container. And how to do it? At first, let's comment this part of code and write it again. Export const my container. Here we should write container equal to create container. And the initialization is different than the create context. In the context, we need to at first tell its type and pretend it to initialize. Then go to the My Context provider, initialize the data value, and in the My Context provider is initialized again. But in create a container, we can initialize the data directly with the customer hook. How can we do that? Let's write const useValue equal to a function which returns a useState value. And in the useState, we just put the data we want to initialize. At first, its age, it's 18, then saving 3000. So that's all. And in the create context, we just written here use value. And keep in mind here we don't need the parentheses, because with parentheses it will return a value, but without the parentheses it returns a customer hook. So here we need a customer hook. Okay, now we can delete this part and also delete this part code, and our code is much more cleaner. Let's now go back to the app file, and there's some errors here, and we need to change the My Context provider to My Container provider. Okay, that's finished. This step is equivalent to this step, context provider to container.provider. And what shall we do in the next step? In the age.info, we should change the user context to container.useTract. So let's comment this line code and write my container.useTract, which returns a value. It's an array, and the first one is the state. The second one is a setState function, which is actually exactly the same as useState returned value. Let's look at what contains in the state. State dot You see, here is the age and the saving. And the set state, you can guess it. It's a function which changes the value of the state. And here we can change the age to state to age. But here add age function, we need to write it. And the const add age equal to a function. And here we can write set state. And from previous state to spread operator, previous state, then age is equal to previous state age plus 1. And so on for the saving info file. And we comment this line code and write const equal to my container dot useTract, and in the bracket is state and set state. And here saving, we should write it to state.saving. And here the add saving, we need to write it again. Const add saving is equal to a function. And in the function, it do the set state and the previous state to spread operator, previous state, and saving is equal to previous state.saving plus 1000. So that should be okay now. Let's check the result. And happy birthday, happy birthday. You see, this time it only rendered the age box. And the same for the saving, add saving, it only rendered the saving box and the age box not changed. Okay, we successfully updated the React context to React tract. But in this code, there is a small problem. I guess there must be someone will say, if I have to rewrite every time the add saving or add age such functions again, then it is very cumbersome. What if I have a lot of functions? I have to rewrite them every time. It will be horrible. So do you have some simplest solutions? Yes, of course. So we can use useReducer to solve this problem. Okay, let's go to the my context provider. And you see here we use useState initialize the use value. Here we can change it to useReducer. And the useReducer, I have already explained the topic in another video. You will find the link in the description. So in the useReducer, it needs two parameters. The first one is the reducer function, which contains all the logic. In our example is add age and add saving, the two logics. And the second is initial value. It is actually the initial state value. So we initialize it here. Const initial value is equal to age is 18 and saving is 13. And now we can define the reducer function. And the reducer function takes two arguments. The first one is state. The second one is action, which means what you want to do in this reducer. And if you like TypeScript, you can simply write the type of the reducer function as reducer. And in the angle brackets, we give first type of the initial value. And the second is the type of the action. We call it T action. And the T action, we can define it here. Type T action is equal to it usually has the first property is type. In our case, it's add age or add saving. And usually we will have another property. It's called payload, which means how many age we want to add or how much saving we want to give. But in this case, we saved this for the sake of simplicity. Now let's go back to the reducer. We can write the logic. Switch action.type. Then, in case of add age, then we return spread operator, state, and age is state.age plus 1. And for case add saving, we will return the state and saving state.saving plus €1,000. So don't forget the default and the return state. That's finished the logic. In this way, we put the add age and the add saving function in the initialization. Now let's go to the age info and remove the add age. And here we should change the set state to dispatch because it is from useReducer. In order not to confuse. And here the add age, we should rewrite it to a function which is dispatch, and it should give the type as add age. And let's remove this line code. Okay, and so on for the saving info, and remove the add saving, and change the set state to dispatch, and change the add saving here to a function. Here and dispatch type is add saving. So that should be okay now. Let's test it. Happy birthday, add saving, add saving. You see it rendered the correct component. Now with the useReducer, we saved a lot of code, but we can still improve our code and make it simpler. If you have ever watched my video about React useReducer hook, you will notice a problem that in the reducer, every time you change the state, you have to deep copy the state because the state is immutable object. But you can use a third-party library called useImmer, with which you can treat the immutable object as mutable object. Can we use this library in react.js? So in the react.js documentation, it didn't mention the useImmer library, but it said you can use it with immer.js. But for this question, I checked their GitHub. The author said, yes, you can. So I'm very sure it works. So let's try the useReducer. How can we do that? At first, we need to install some library, npm install immer, and useImmer. And we can change the useReducer to useImmerReducer. Then, in the reducer type, we change it to immerReducer. So now we can simply treat the immutable object as mutable object. state.age. Now you can write equal to 1. And don't forget the break. And same for the saving, remove this part. And state.saving, you can direct write plus equal to 1000. And the break. And the default is simply break. That's all. Let's check the result. Happy birthday. Happy birthday, correct, it render only itself. And saving, it only render itself. Cool. Okay, let's look at something else. So, in the age info, and let's check the my container dot, you will see there are something like use selector, use tracked state, and use update. What are they? It's actually very easy to guess. My container dot use tracked state, it will return a state value. And const dispatch is equal to my container dot update. Why there are such functions? Because sometimes we don't care about everything. For example, sometimes we only care about the state. We don't want to have the dispatch function. For example, in this case, we can remove the button function. We only care about the state. So in this way, our code will be more cleaner. And another thing is my container.useSelector. It returns certain state value. For example, here we can write state return state.age. And const age is equal to, and in this case, we can call it directly age. So that's all. The goal for these functions is make your code more cleaner and faster. Okay, this is all about React Tract. Thanks very much for watching, and see you next time.
Don't stop.